Hello everybody, this is the third clip of our chapter 6, which is about a multivariable calculus. Okay, as we have learned before, if you are given a function z equals to f of xy, then you can find a partial derivative of a function f or z with respect to x, or we use f sub x, which is a partial derivative that your y regarded as a constant. Okay, and then you can use your calculus 1 to find a derivative. Or if you want to find a derivative of a function f with respect to y, or f sub y, it is again is a derivative with respect to y when you regard your x as a constant. Okay, and we also recall what you have learned from your the one before midterm, that if you have a cost function, for example, of one variable, a derivative of this cost function is so-called a marginal cost, and you got its own interpretation of the marginal cost, right? Like the increment of your cost if you produce one more product, okay, from what you have produced. Okay, so today we are going to talk about this kind of interpretation as well as a simple application of a partial derivative. So of course, I mean, in terms of cost function, you can have the cost function that depends on several more products, right? And you can find a marginal cost with respect to x, a marginal cost with respect to y, and both of them has their own interpretation. So let us take a look. Okay, so the first one, you suppose that a manufacturer produces x units of a product x and a y units of a product y, and a total cost, okay, of to produce these two products, okay, is a function of x and y. This one is called a joint cost function. So a joint cost function depends on x and y. Usually we use a c equals to f of xy. So the derivative with respect to x, okay, it is a marginal cost with respect to x, which is the rate of change of the cost, okay, as your x change but your y is fixed. So on the other hand, if you find a derivative of a cost with respect to y, it is a marginal cost with respect to y, and the rate of change of your cost c, okay, with respect to y when a variable x or a value of x production is fixed. Okay, so let us talk about this example. Okay, this example says that a company manufactures two types of skis. Okay, one is the Lightning and one is the Alpha models. Okay, suppose that the joint cost function to produce the x pair of Lightning and the y pairs of Alpha model per week is this kind of cost. Okay, 0.07x squared, 75x, 85y, and 6,000. You see it's expressed in dollars. Okay, so you want to determine the cost, a marginal cost, as your x equals to 100 and your y is 50. And of course, okay, the most important thing is to interpret your result. Okay, interpret the quantity that you got. So let's see, because they want to find a marginal cost, but they didn't really determine which cost that which marginal that they want. So it means that you need to find both of them. So first, a marginal cost with respect to x, okay, which is the derivative with respect to x. Again, so if you take a look, here is a variable x, there is a variable x, the rest they are a constant under consideration. So this one is a 0.07 2x and a 75, and then the rest they are 0, or you can calculate it to be 0.14x and 75. So of course the marginal cost with respect to x, okay, when your x is 100 and your y is 50, okay, So this one is the way we write, okay, as you want to evaluate this partial derivative at a particular point. Okay, you can write this way, or you can simply write as c sub x, and when your x is 50, your y is when your x is 100, your y is 50. Okay, you can write this way as well, and it is a what? So you just plug in your, because right now only the x that survive, so you can just plug it in there. Okay, so you have 0.14, your x is 100 plus 75, so it is 75 and 14, okay, which is 89. Okay, 89. This one is the $89 per pair, right? This is a dollar per pair. Okay, per one pair. Per one pair. Okay. What should be the interpretation? What should be the interpretation? Okay, so it means that if you produce, if the company, not you, right? If the company produce, okay, one more pair of which model? Lightning model from what? From or the original of 100 pair. Okay, so if you produce one more from 100 pairs of lightning model, okay, but fix, okay, the production of the second brand to be 50, okay, then the cost, because this is positive, right, increase by $85. Okay, so the keyword is that you produce one more from the original production that you did it right now, but you need to fix the second variable, because right now you do the first variable partial derivative, right? Okay, and then the keyword of either increase or decrease by how much. Okay, that will be the important keyword that we need. Okay, so now let us look at this problem again, but on the other aspect. Okay, instead of the one with respect to x, let's see this problem again, but you find a partial derivative with respect to y, which is a marginal cost with respect to y. Okay, so this one, don't forget that it is a marginal cost with respect to x. So let us do it again, but the marginal cost with respect to y. So you are going to find the dc dy. Okay, so here your y is right there alone, so the rest can be regarded as a constant, right now. So the first term becomes 0 after finding a derivative with respect to y, the second term as well, the third term is 85, and then the last term, because it's already a constant, so it's 0. So it means that, I mean, no matter how many pairs you produce, okay, the derivative with respect to y at each and every level of production, this also $85 per pair. Okay, so this one is your marginal cost with respect to y. Okay, with respect to y. So what is the interpretation? So it will be the same thing, right? That if the company produce, which brand produces the Alpine one more pair of Alpine from the original production of 50 pair, okay, but fixed a level of production okay, the lightning to be the same 100 pair. So, okay, then the cost of producing, okay, these two things will be increasing by $85. Okay, but actually if you really look at it, actually this 85 is not depends on any x or y. So even you produce, right, if even right now you are not producing 50 pairs and fix this one to be 100, it always 55 constant. Okay, however, I mean, the normal way to give the interpretation is that you are going to produce one more, okay, from the original production, but the right now the first variable, okay, component must be fixed. You see, the first variable is fixed, then this one either increase or decrease by how much, so this is the simple way to give the interpretation. It's just like, what should I say, a longer way than what you have done before the midterm exam. Okay, now let's look at some other application, but it is same idea. Okay, it's actually the same idea. This one is so-called marginal productivity. So usually the output of a product depends on many factors of the production, right? For simplicity, let us suppose that the output depends on the labor L and the capital K. Okay, you may say that, hey, why don't we use C? Because the C is already preserved for the cost function, and we use the K instead because in German the K is actually the C in English. Okay, so we use the L and the K, the L for the labor, the K for the capital. Okay, so if a production function, so this P is a production, okay, a production function depends on L and K. Okay, gives the output P when the producer uses L units of labor and K units of capital. Okay, this function is called, as I told you, a production. So to find a derivative, okay, to find a derivative of this production with respect to a labor L is a marginal productivity with respect to L, of course. Okay, so and this one is the rate of change of a production with respect to a labor L when your capital is fixed. Okay, so you want to know, like, what's the effect of changing the number of labor, okay, but your capital still the same. Okay, on the other hand, if you want to see the effect in terms of production, if you change the capital, okay, if you change the capital but your labor are fixed, that will be a derivative of P with respect to a K, okay, a marginal productivity with respect to K. So let's see, usually a manufacturer of a popular toy has determined that the production function depends on P equals to a square root of LK, You can look at it as L raised to the power 1/2 K raised to the power 1/2. Okay, of course the L is the labor hours per week and the K is the capital. Okay, and the capital is expressed in hundreds of dollars per week. Okay, required for a weekly production of P gross of the toy. So you would like to determine the marginal productivity of a functions and then you need to evaluate them at L is 400 and K is 16. And of course, again, the most important thing is to interpret your result. Okay. This is one more time. They didn't indicate which marginal that they want. So it means that you need both of them. You need both of them. So if you find a derivative with respect to the L first, okay, the partial derivative with respect to L, so it means that your K regarded as a constant, okay, and the derivative go directly to L raised to the power 1/2. So you have 1/2 and then square root of L, okay, like that. Or you can write as square root of K over 2 square root of L. Okay, this one is a marginal productivity with respect to L, with respect to the change of the labor. So if you want to find a marginal productivity with respect to L when your L is 400 and your K is 16, so you just plug in your K to be 16, your L to be 400. Okay, so this one becomes a what? This one becomes 20. So you have a 40 and a 4. So you have 4 over 40. Or it is 0.1. Is it 0.1? So what is the interpretation? What's the interpretation? So maybe we may need, we can write down right here to interpret. So it means that if the manufacturer, okay, increase one more labor of hours, I mean the labor hours per week, one more labor hours per week from what's the original number, 400 labor hour, so okay, per week, but fix the capital to be what? To be 16 hundredths of dollar. So it is a 1600, right? Sorry, 16 hundredths of dollar per week. Then, of course, the production increase, right? By how much? 0.1 gross of the toy, by 0.1. So where is the keyword? The keyword is that the manufacturer increase one more labor, you see, because it is a derivative with respect to L from the original of 400, and it is fixed your capital to be 1600, and because it is positive, so it means that the production increases by this much, okay, gross of toy. Well, right? Okay, so all these are, you know, the important keyword. Okay, you can replace or rewrite this sentence into a good English. Okay, but all these keyword must be there. So what else that we can find? The other thing that we can find is the partial derivative with respect to k, of course, right? So if you want to find a partial derivative with respect to k, so your L is fixed and your k, derivative of square root of k, you have 2 square root of k. So it means that a partial derivative with respect to k, or a what? This one is a what? Is a marginal productivity with respect to k. Okay, whenever your k is 400, your L is 16, it is a what? Your L is 400 square root, your k is 16, so you end up with 20 over 8, is it? 2 and 4. Okay, so the 20 over 8, okay, you may saying that it is 2.5. Okay, it is 2.5. So what is the interpretation of this number? Okay, again, it means that if the manufacturer increase, so now which one that it increasing? So the change is in the capital. Okay, increases the capital by 1 more unit, but this time the 1 more unit of capital, it is by what? $100. Okay, from where's the original? $1,600. Okay, this is the original, but fixed the labor hour to be 400, then the production increases by how much? 2.5 gross of toy. Okay, then if you are the manufacturer owner, you can decide which one to increase, right? If you increase the labor of hour, then it is the production will increase by this much. But if you increase the capital, then the production will increase by this 2.5. Okay, so it depends on your situation, and it depends on your decision which one that you are going to choose. Okay, depends on several factors. Okay, but these are the information that you have from a production function and also a marginal productivity. Okay, now for example, if you are estimated that a weekly output of a certain plant is given by this one again, because we talking about the output, this one is a production again. Okay, a production function depends on x and y like that. Your x is a number of skilled workers, and your y, of course, a number of unskilled workers. So currently the workforce consists of 30 skilled and 60 unskilled. So you want to estimate the change in weekly output that will result from addition of one more, which one change? Skilled worker, and the number of unskilled unchanged. So this is another way of asking question. Instead of saying that, hey, why don't we find the marginal productivity with respect to this and that, they just interpret your marginal productivity in terms of word. Okay, so they want you to find the change in weekly output, so the change in weekly output is a dq, okay, is the derivative of a function q. But then with respect to which one? So the one that is changed is the skewed, so the skewed is the y, so the change is in the skew is the x, so the change it in terms of the x variable only, and your y is unchanged, so it means that your y is fixed, okay. So it means that this one you are going to find a derivative of q with respect to x, and whenever your x is 30, your y is 60. Okay, so let's see what happened. So you need to find at the arbitrary point xy first. Okay, so here your x is a variable, there your x is a variable, there your x is a variable, and the rest they'll be regarded as a constant. So this one is 1200. A derivative of x is 1. The second term is all constant, so it is 0. The third term, your y is a constant, and the derivative go directly to x squared, so you have 2x. And the last one is a 3x squared, and I mean, sorry, not the last one, the one before the last one is 3x squared, and the last one is a constant, so 0. So it means that if you want to find a derivative of a production with respect to x, as your x is 30, your y is 60, then you replace it over there. So your x is 30, your y is 60, this one is another 30 square, so you have 1200. You got 36, is it, hundreds, and you have 20, sorry, minus 27 hundredths. Okay, so if you want, you can do it, I mean, using your brain or using your calculator, and it is given you 21 hundredths, okay, units. So what does this mean? If you just add one more skilled worker, okay, originally from 30 skilled worker that you use right now, okay, and you're unskilled, okay, you can keep it at 60. The production will increase, you see, increase by these many units. So do you want to do it or not? Okay, so what if okay, what if you increase, instead of a skill, what if you increase your unskill by 1 from originally of 60, okay, but you fix your skill still at 30, what will be the change in the Q, the production? So it means that you want to find a derivative of Q with respect to Y. What will be the change? So if you have these information, then you can determine, or you can decide by yourself whether you are going to, you know, add a skilled, or you want to, you know, add the unskilled. Depends on yourself, right? And depends on some other factor. For example, the you know, the money that you need to hire the skill, or the money that you need to hire the unskilled, okay, depends on that kind of thing as well. Okay.